Hi everyone, this is Chris Warner with ECN Magazine and ECNmag.com. I'm at Design East. I'm in the Microchip booth, and we're here to talk about a new mid-range PIC microcontroller 8-bit offering from Microchip. It's comprised of 15 families off of 3 lines. It's highly scalable, up to 128 kilobytes of flash, and the main takeaways are the cost savings, both in terms and real estate savings, and reduced complexity for designers. And a lot of it has to do with a new technology that Microchip has integrated into this offering called active clock tuning. So I'm here with Wayne Freeman and from Microchip. And Wayne, I guess the first question I have for you is, since cost savings and reduced complexity are such big issues for designing with USB, and accuracy is also a very big issue as well. How is it all achieved for USB 2?
So for USB 2.0 communication, the accuracy required of both the host and the device attached to the host is 0.25% accuracy over the temperature specification. What we do to achieve that is basically implement a technology called active clock tuning. Now, what that does is it allows us to retime our internal clock in our microcontrollers to the USB communication with the host, so that every 1 millisecond we're basically retiming the oscillator to achieve that 0.25% accuracy. That allows us to do it very, very low cost and completely eliminate the crystal.
Okay, and these also feature Microchip's extreme low power technology. Can you describe that for us?
Yeah. Extreme low power is Microchip's secret sauce for low power performance. In this particular series of microcontrollers, we achieve down to 20 nanoamps in sleep mode and down to 35 microamps per megahertz when in active mode. Now we do that with basically a little bit of mode switching, powering down certain parts of the chip, and other things that allow us to really optimize our microcontrollers for the power consumption. It's really important for embedded USB, where 90% of the time these USB applications aren't actually going to be plugged into a USB host. They're going to be running on a battery.
Okay, so we're talking about a breadth of scalability from 14 to 100 pins, and that certainly opens up a good variety of application areas for it as well.
Oh, of course. We have products in the 14-pin range that can do USB plus battery charging, or USB plus connection to a legacy serial network like RS-232. All the way up to our 100-pin parts in the J94 family, which allow us to do LCD plus USB. In fact, that's our first USB family in 8-bit with LCD controllers.
I was just going to ask you about the LCD control. So what about some of the integrated peripherals as well? I mean, there's a lot in there, right?
Absolutely. So what we focus on in 8-bit at Microchip is to provide the ability to both sense and control. That allows us to basically provide our customers with the hooks to connect to the outside world that they're typically using in their application. So we've got peripherals like the CTMU, or Charge Time Measurement Unit, which allows us to do touch sensing and measurement of temperature, flow rate sensing, level sensing, humidity sensing, perhaps even solving world peace, in addition to the LCD and the USB.
Okay, I was just going to ask you about the capacitive touch sensing as well. What allows it to meet the touch sensing requirements?
So we have an entire division devoted to human-machine interface at Microchip, and they develop a lot of the software that we implement on many of our different PIC microcontrollers. So all 3 of these families actually have the ability to do certain types of touch sensing using different algorithms and different code that we provide for free to our customers. So the first 2 families, the 14-pin up to 40-pin, have ADCs that allow them to use the capacitive voltage divider method, and the high-end family has a CTMU, which allows you to do touch sensing.
Okay, and finally, what kind of development support's available?
We've got some excellent development support. We actually have 3 different development platforms depending on the product family that you're using. We have our higher end 100-pin J94 family that's supported by our PIC 18 Explorer board and our LCD Explorer board. We also have all the way down to our 14-pin and 20-pin boards, devices that are supported by the low pin count USB development kit, which is available on our website and through our partners.
Well, thanks so much for your time today, Wayne. Again, this is Chris Warner from Design East, and Wayne Freeman from Microchip has just demonstrated the mid-range 8-bit PIC microcontroller family from Microchip. It's highly scalable, 14 to 100 pins, cost savings, board space savings, complexity savings, and looks like a very comprehensive offering from Microchip. Thanks so much.
Thank you, Chris.